This is your host, Ankur, and today we are going to be looking at the top AI research papers. In fact, the top 10 AI research papers in the week 12, that is the week of March 19th to March 26th. We will be looking at the research papers in the domains of large language models, computer vision, and NLP. Hi, so let's look at the first paper. The paper is called UPRISE, Universal Prompt Retrieval for Improving Zero-Shot Evaluation. Now, what is discussed in the paper is that the large language models like the GPT-3, OPT, and Bloom, they've got impressive capabilities, but their performance can be improved by enhancing their ability to follow prompts and creating procedures for prompt engineering. Now, how to do this is you can either do it by fine-tuning the LLMs or by multitask tuning. But these are very expensive methods, and they're also constrained by the processing resources. Now, what this paper discusses is a lightweight new method called UPRISE, that can adjust the prompts from a pre-constructed pool of data automatically to improve the LLM performance. So let's see how this works. So we have, now what you see here is two stages. You have the training pipeline and you have the inference pipeline here, right? Now in the training stage, a frozen LLM model, this is a frozen LLM model, is used to supervise the tuning of a prompt retriever. Now how this happens is the prompts are given to both the frozen model here as well as to the prompt retriever. And what the frozen model does is it calculates the task scores against each of the tasks that are provided to it. So it calculates the task scores, and these task scores are used to tune or used to supervise the contrastive learning of the retriever. So once this has been tuned to improve the contrastive learning of the retriever is now tuned for the inference stage. Now what happens in the inference stage is that this same prompt retriever, which is the tuned one, when it is given a prompt, the prompt retriever initially retrieves the positive prompts that it has already been tuned on, and those prompts are passed to the language models to predict a task output, right? So the UPRISE, what it does is it can solve the fact-checking problem that ChatGPT-like models faces, and it can also improve the performance of even the strongest of the LLMs. We are going to be looking at is called aligning text to image models using human feedback. Now, researchers from Google and Berkeley have developed a three-step solution to align AI-generated images with the text prompt using human feedback. Now, what they've done is they've fine-tuned the reinforcement learning with the human feedback, the RLHF method, to improve the image generation models. Now, what the process is, it involves generating a diverse set of images from the existing models, evaluating them with the human feedback, and then training a reward function to better align the image outputs. So what you see on the slide here is it's a three-step process. In the step one, we collect the human data, we get the output, using the image generation models. And then in the second function, we create a reward function, which is the reinforcement learning with the human feedback. So we provide that. And in the third stage, we use a reward-weighted likelihood maximization algorithms to fine-tune the RLHF method. So by doing this, we found that this resulting method was tested using stable diffusion and on 27,000 different text-to-image pairs. And it demonstrated a highly improved compositional generation and much better object color specificity. Let's look at the next article. The next article is called Texture, Text-Guided Texturing of 3D Shapes. Now, this article discusses the development of a new AI framework called Texture, which is designed for text-guided texturing of 3D meshes. Now, what happens in this framework is it involves applying a fully denoising process on the rendered images using a depth conditioned diffusion model to generate highly realistic images. The selected 3D mesh, as you see here, the selected 3D mesh is partitioned into a trimap of keep, refine, and generate regions, allowing for the generation of realistic and consistent texturing in merely minutes. The ability to generate realistic images from the text has a wide range of applications, as we are aware, from art to entertainment, where it can be used to create visuals for books, movies, and video games. The framework can also be applied to fields like product visualization, where 3D models are essential. Hi everyone, so let's look at the next paper. Now, this paper is called ART, Automatic Multi-Step Reasoning and Tool Usage for Large Language Models. Now, this paper talks about a new framework called ART, which is the Automated Reasoning and Tool Usage. Now, that has been developed by researchers from multiple institutions to help large language models adapt quickly to new tasks using in-context learning. So this is again part of the prompt engineering. Now, how this tool works is it automatically generates multi-step reasoning chains for the new task by selecting similar task decompositions from a task library. So what you see here is once a task is given, the tool selects the similar task, decomposes the task given and selects similar task from a task library. And then it takes the output of the LLM model, which is a frozen LLM model, the LLM output, and then it uses human feedback to use the tasks that are being selected from the library, and the output of the LLM model, it uses the human feedback to fine tune it. Now, the LLMs receive demonstrations from ART on how to break down the instances of related activities and how to choose and apply any tool from the tool library. Now, the response of this is that the ART, it outperforms direct few shot prompting on both Big Bench and the MMLU task by almost 11 percentage points. And also it outperforms even the best known GPT results on tasks that require mathematical and algorithmic reasoning by over 12.5 percentage points. The next paper we are going to be looking at is called Active Prompting with Chain of Thought for Large Language Models. Now, the large language models have strong reasoning capabilities, making them useful in applications like information retrieval, chat assistance, writing assistance, and other applications. However, they face challenges when it comes to complex reasoning tasks. In context learning, where LLMs are given a set of example question and answers to learn from, has been shown to improve their reasoning capabilities. The proposed paper, which is called as the active prompting approach, leverages uncertainty to select the most informative questions for annotation, reducing the human efforts. So how this happens is this takes place over 4 stages as is shown in the diagram. The first stage is called the uncertainty estimation. Now, where a few questions are provided, we query the large language models with a set of possible questions, and the large language model generates the answers. First stage itself, once the large language model gives the answers to the questions, these questions are assigned an uncertainty level based on the disagreement seen with the answer. So they are given an uncertainty level. Now, the second stage is called selection, where according to the uncertainty, we select the most uncertain questions for annotation purposes. And as you rightly guessed, the third stage is annotation, where we involve human beings to annotate the selected questions. And finally, the fourth stage is called the inference stage, where the model provides inference for each of the selected annotated questions. Now, the proposed solution outperforms the baseline methods in terms of accuracy and efficiency, and this has been found to improve the LLM's performance on the reasoning task. Article we are going to be looking at is called Objaverse, a universe of annotated 3D objects. Now, this article discusses the importance of having good quality data sets in machine learning and artificial intelligence applications. The article highlights the lack of high quality quantitative data sets for 3D data, despite the abundance of other data sets for the other areas of AI. And to address this issue, the prior research team from the Allen Institute of AI, they created this Objaverse 1.0, which is a large-scale data set comprising of over 800,000 3D objects with annotations on captions, tags, and animations. Now, this Objaverse is a publicly accessible and available for download on the Hugging Face. The dataset includes diverse visuals of animals, cartoon characters, vehicles, food delicacies, interiors and exteriors of large spaces, and over 44,000 animated 3D objects. So if you look at the distribution here of the object categories, you find 77,000 architectures, 62,000 character creatures, 52,000 furniture homes, 47,000 science and technology. So the dataset's capabilities have been demonstrated through various experiments across different domains, and this has already been used by the Meta and the researchers at the Columbia University. The researchers hope to revolutionize the field of 3D vision by providing the AI community with the access to a large, diversified data set that can be utilized across various AI disciplines. The next article we are looking at is semantic dedupe, data efficient learning at web scale through semantic deduplication. Now, this article discusses the importance of self-supervised learning in the recent advances in machine learning, particularly with the availability of large unlabeled datasets. However, the power law scaling of test error with data amount limits the marginal improvements that can be achieved with additional data, highlighting the need for data efficiencies. Now, the researchers in this paper have proposed SemDeDup, a method for detecting semantic duplicates in large data sets, which can significantly reduce the training time and improve the performance out of the distribution task. Now, this method involves using k-means clustering on a pre-trained model to identify nearby data points that fall below a cutoff. The study applies the SemDeDup to C4, which is a large text corpus, and LeIon, which is a multimodal datasets with 5 billion image to text pairs now, and achieves an efficiency of about 15%. And there is a much faster learning and with minimal performance loss. The goal is to eventually have much smaller data sets to make massive models more accessible. So the next article we will be looking at is called Dreamix. Now, this is video diffusion models or general video editors. Now, in this topic, the text-to-image and the text-to-video synthesis are challenging tasks in computer vision and natural language processing. Diffusion models that have emerged as a powerful technique for addressing these problems, leveraging deep neural networks to generate photorealistic images and videos that align with textual description. Now, the paper talks about Dreamix, which is a novel text-to-image AI framework, which is based on the diffusion models that uses a degraded version of the original video as initialization and is fine-tuned on the original video to improve fidelity. To address the challenge of video editing using diffusion models, the authors suggest a new approach called mixed fine-tuning. Now, in this approach of mixed fine-tuning, what they do is the video diffusion models are fine-tuned on individual video frames while disregarding the temporal order between those frames. Now, this leads to a significant improvement in the quality of motion edits by improving the motion editability while maintaining the temporal consistency between the frames. So if you look at the input video, now this input video is of a monkey eating monkey, while what the Dreamix has done is, by using the prompt of a bear dancing and jumping to upbeat music, moving his whole body, they have transformed this input video from a monkey's video into a bear's video while maintaining the fidelity to color, posture, the object size, and the camera pose. Resulting in a temporally consistent. We're going to be looking at is called X-Avatar, Expressive Human Avatars. Now, the study introduces X-Avatar, which is an innovative model that can capture the complete range of human expressions in digital avatars to create realistic telepresence, augmented reality, and virtual reality environments. Now, X-Avatar is an expressive implicit human avatar model which has been developed by the ETH Zurich and the Microsoft researchers that can capture high fidelity human body and hand movements, facial emotions, and other appearance traits. The model can learn from the complete 3D scans, as you see here, or the models can also learn from the RGBD images, right? Producing a comprehensive models of bodies, of hands, facial expressions, right, and looks. The study also presents something called as X-Humans, which is a data set with 233 sequences of high quality textured scans from 20 subjects, displaying a whole range of body and hand motions and facial emotions. Now, this X-Avatar, the way the X-Avatar captures the facial expressions and the hand gestures makes it the first implicit human avatar model that captures the richness of the human state in a unified article for today, and it's called Pics to Video, Video Editing Using Image Diffusion. Now, this article discusses a new approach called Pics to Video, which is a training-free model for text-guided video editing using image diffusion. The two-step methodology involves using a pre-trained structure-guided image diffusion model to perform text-guided edits on an anchor frame and then progressively propagating the changes to future frames. So if you see here, this is the input video here. We first carry out the text-guided edits on this anchor frame, and that is progressively propagates the changes to all the future frames, right? Using the self-attention feature injection process. Now, Pics to Video has been evaluated on various real video clips and compared to other state-of-the-art approaches, demonstrating its ability to strike a balance between this respecting the edit and maintaining the temporal consistency without requiring retraining. Now, this approach seems promising and versatile and can be applied to a wide range of video edits without needing the compute-intensive pre-processing methods or fine-tuning approaches which are specific to for today. Thank you very much, guys. I look forward to meeting you next week. Have a good weekend. Bye-bye.